Algebra 1, Section 2.4 is going to take what you learned from 2.2, well actually from 2.1 to 2.3, and combine them together. So far you've been lucky we're doing just one step, but of course with math it's never just that easy. So in this sense, we're doing all the same things, and we're not introducing any new rules. You're just simply applying all the rules to one section. So the first one is asking us to solve and graph, okay? So basically I want to isolate B. And so we remember the order of operations. Now we're going to do the opposite. When you're solving, we're going to do the opposite. I'm going to take the things that are furthest away from B away first. So since 45 is the furthest away, I'm going to go ahead and subtract it from both sides. Okay? So this cancels out. And remember, because I subtracted 45, I can only do that because I would have to do it to the other side. So here I'm going to add 2b. This is, well, I don't have to put the addition sign. So 2b, I'm going to bring it down, okay? And then I have, I didn't, and remember the rule, I didn't multiply or divide by a negative number, so the sign stays the same. And this is 16, right? And then I go ahead and, because 2 is attached to b by multiplication, I'm going to go ahead and do the opposite, which is division, and this cancels out. And again, I have to do it to the other side. I end up with b is greater than 2. Okay? So if I want to graph this, I don't know why one arrow is bigger than the other. It's going to be open or closed circle. Well, in this case, there's no line underneath, it's going to be an open circle. And B represents all the numbers that are bigger than 2. Because B, the bigger sign is going to be, so anything bigger than 2. Okay? Alright, our next one is similar. I'm doing 8. I'm going to subtract positive 8. I know this negative is here, but that negative is attached to the 3. It's not attached to the 8. So 8 is still positive, okay? So that means the opposite of positive 8 is negative 8. And I'm going to do that to both sides. This cancels out, and I end up with bringing this down. I have to bring the negative. See, I didn't have to bring the positive here because positive 2 is the same thing as just 2. But negative 3 is not the same thing as just 3. I have to include the 3. So, I'll leave that. You got it. So, I'm going to have to bring that negative 3y down. And again, I didn't multiply or divide. I did subtract, but I didn't multiply or divide. So this stays the same. Okay? And this becomes 21. Right? So negative 3y is attached, so I'm going to divide negative 3 to both sides. This cancels out because this is attached to the y by multiplication, so I have to get rid of it by negative. Okay? And then I do y. But what happened here? Sometimes you can get so caught up that you don't pay attention, but we divided by a negative number. You see that? Negative 3 on both sides. So now what do I have to do to the sign? Now I have to flip the sign. 21 divided by negative 3 is negative 7. Okay? And I can graph. This is 0, negative 7, 7. This has a line underneath, so I'm going to do closed circle. Okay? And y is all the numbers that are less than negative 7. Okay? Negative 7 is the bigger number than all of y, so anything to the left. Right? So let's try. I'm going to go ahead and circle this with this, and this with that. Sorry for the messiness. Okay. So now we're going to be solving more multi-step equations. Okay, we're going to first combine these. You see how this negative and this negative are together? Okay, so when two negatives are together, we get a positive. So this is the same thing as saying 2 plus 10 is greater than negative 4t, right? Because these negatives together make a positive. So 2 plus 10 is 12 is greater than negative 4t. So we're going to go ahead and we're isolating t, right? So I'm going to divide both sides by negative 4 because the opposite of multiplication is division. And again, I'm multiplying by what? A negative number. So I have to flip the sign. So 12 divided by negative 4 gives me a negative 3. And now I have to flip that sign, giving me t. Okay? All right. Our next one, we have a parentheses. And according to the order of operations, we're going to do the parentheses first. And what happens to the parentheses, we have to distribute. So we're going to take this negative 4 and I'm going to distribute here. So negative 4 times positive 2 gives me a negative 8. Okay? I also have to distribute it, but not just to x, but whatever's in front of x, if it's positive or negative. In this sense, it's negative. So negative 4 times negative x, and remember, when the negatives are together, are being multiplied together, then I get a positive. So this is positive 4 times x, because they're not like terms, I have to leave it with 4x. Okay? And I haven't moved anything to the other side, I'm just simplifying one side, so I'm not flipping or anything. Right? So now again, what's the furthest thing away from x is 8, negative 8, so the opposite of negative 8 is positive 8. I'm going to go ahead and cancel this out. I end up with positive 4x is, positive 4x is greater than or equal to 8 plus 8 is 16. Okay? And then from here, I'm going to divide both sides by 4. Okay? These cancel out. And I end up with x is bigger than or equal to 4. Right? My next one is fractions. And when we're multiplying fractions, that's one thing, but in this case, we're adding and subtracting. So whenever you add and subtract fractions, you have to find a common denominator. In this case, 3, 2, and 3 are not all the same. And I can't turn 2 into 3, so I have to change everything, which I know is annoying, but it's logical, right? I can't be adding and subtracting from different denominators. If I have different pizzas with different numbers of slices, it's not the same division for each box of pizzas. If I have one with 8 pieces and one with 16 pieces, I'm going to divide them up differently, okay? So in order for me to divide them up the same, I have to then find the same denominator. In this case, 3 and 2, okay? They all have 6 in common. So in order for me to turn this into 6, I have to multiply it by 2. So I have to multiply the top by 2 and the bottom by 2. So 2 times 2 is 4. I don't have to apply it. I don't have to apply it to everything as long as I'm keeping it the same. Basically, 2 over 2 is 1, and 1 times anything is itself. So I'm not changing the value. Okay. Now, if I did multiply it by 3 over 2, that's a whole different fraction. So I can't legally do that unless I do it to every single fraction. Okay. So 2 times 2 is 4. And 2 times 3 is 6. That's my goal. I want it to look like 6. So this is F. All right, now I want this to look like 6. It's not the same rule as here because 2 times 2 is 4, and I want it to look like 6. So I have to multiply this top and bottom by 3. 3 times 1 is 3, and 2 times 3 is 6. And then for this one, it's 3. So it's the same rule as here. I'm going to multiply top and bottom by 2. 2 times 1 is 2, and 6. Now that I have like terms, I can go ahead and add and subtract where I want. So in this case, the furthest thing from my variable f is 3, 6. So I'm going to subtract 3, 6 from both sides. Okay? So in this case right here, this cancels out, and I do 4 over 6f is greater than 2 minus 3, 6 is 2 minus 3, 6. I do only the numerator, so 2 minus 3 is negative 1 over 6. Okay? And I'm going to go ahead and multiply this by the opposite, so 6 over 4. Right? Because I want to get rid of it, and how I get rid of a fraction is I flip it and I multiply it by its mirror, flipped mirror. Okay? And I have to do the same thing here, 6 over 4. So this cancels out, leaving me with just f. Okay? And I didn't multiply or divide by any negative, so I'm going to keep it as greater than. And then negative 1 times, this 6 and this 6 cancel out, leaving me with negative 1 over 4. That might have been a little complicated. If you have a problem, we can discuss it in class. Just let the teacher know. Go ahead and try page 123, numbers 4, 7, 10. Page 123, numbers 4, 7, 10. And I will see you in class.